So good evening, dear children. Am I audible to you guys?
Yes, sir.
You'll have to be louder. Am I audible to you guys?
Yes, sir.
Yes, sir.
Awesome. Okay. In the previous class, we actually completed this particular chapter that is congruence of triangles. So today, what we are going to start is basically the 14th chapter that is circle. That is nothing but page number 90. So, so here is the chapter circle. Let us first revise some facts about the circle. First of all, as you can see, there is a circle over here. So there are a few lines. One is AB. In between, there is a point O. Then there is OC. Then there is PQ. Let us understand what these things are. First of all, OC. O, which is nothing but the center. C, which is nothing but a point in the circle. So this is the circle. Circle ka circumference means border, and is circumference पर जो भी point है, whatever point you can see on the circumference is C. One of the point is C. And if you join a segment from center to the circumference, that segment is called as radius. And diameter is what? Diameter is basically a line which is joining one end of the circle to another end, and which is line means segment, which is joining one end of the circle to another segment of in the circumference which is passing through the center is called as diameter. So diameter is AB in this case. So PQ is not diameter because PQ is not passing through center. AB is diameter because it is passing through center. And what is PQ? Any particular segment which are joining two parts of the circle but not passing through the center is called as chord. CHORD, chord. First of all, what is a circle? Circle is a figure consisting of all those points of a plane which are equidistant from a fixed point. So this O is that fixed point, which we call it as center of the circle. And this circle consists of so many points. As you can see, wherever my mouse is traveling, um, all that path has various points. So there are like thousands or maybe lakhs or maybe crores of points over here. When all these points, like if you consider this particular point, it is, let me say, it is at a distance of two near, let's say 10 centimeter or maybe 5 centimeter from O. And let's say B is again 5 centimeter from O. If you measure this distance, the C is also at a distance of 5 centimeter from O. If you see this point, Q is also at a distance of 5 centimeter from O. P is also at 5 centimeter. A is also at 5 centimeter. So what we understand, any point on this particular path is basically at equidistant from this particular O. So that is the definition of a circle. It is basically a figure which consists of all those points of a plane which are equidistant from a fixed point, and that particular fixed point is called as center of the circle, and the definite distance is called as radius. So how much ever dis is the distance between this particular fixed point and the points on the circle, that distance is called as radius. In short, center से लेकर circumference तक का जो भी distance है, that is called as radius. What is a radius? I've already explained you what is a radius. What is a called chord? That also I have explained. What is a diameter? That also I have explained. What is a secant? Secant is what? By the way, before I proceed to secant, let me just remind you that the distance between O and C is radius, or maybe the segment. Segment between O and B is radius. Segment between O and A is also radius, and A and B is diameter. As you can see, in one diameter, there are two radiuses. Okay, two radiuses. The plural of radius is called as radii. Okay, RAD double I. So I'll just write it down just for your understanding. Singular radius, plural radii. So when there are more than one radiuses, we call them as radii. Okay. जैसे कि बाकी सब जगह पे we simply put an S. For example, fact. Fact is singular, facts means plural. Similarly, over here, radius is singular and radii means plural. For example, over here, OC is one radius, OB is another radius, and AO is another radius. So all three combined, they are called as radii. Okay. And similarly, OB and OA both are radii. Two radii comprises of one diameter, or maybe one diameter will have one radius and another radius. Two radii it will have. I hope it's clear now. Okay. Hence, they have said this particular diameter is always two times radius. Two multiplied by radius. This is the formula for diameter, length of the diameter. Now, what is a secant? A line which intersects the circle in two different points are called as secant. So, in short, अगर मैं बोलूँ, for example, this is the line which is intersecting a circle at point A as well as at point B. So, this particular line is called as secant. Now, in simple language, I can say that this particular segment starting from A to B, this is called as chord. So when basically, if it's a segment, it's called as chord. If it's a line, we call it as secant. So this is the difference between a chord and a secant. Chord को दोनों तरफ से खींच के line बना दो, it becomes a secant. As simple as that. Sixth one, tangent to a circle. So what is a tangent? So whenever, as you can see, there is a circle and this is its center and this is the circumference. So circumference may let me consider one point. And from that one point, if I am drawing a line, that particular line which is touching the circle only at one particular point is called as tangent. A line which lies in the plane of the circle and touches the circle at one and only one point is called as tangent. The point in which the tangent touches the circle is called as point of contact. So this particular P in this case is point of contact. In the above figure, line X, so this is a line X, is a tangent to the circle with center O, and P is the point of contact. P is the point of contact. Now there are few properties of tangent. The first property, the tangent to a circle is always perpendicular to its radius at the point of contact. For example, this if this is the tangent, this is the point of contact, this is the point of contact, this is center. If I'm joining a radius from center to this particular point of contact, and when I see the tangent, it is observed that radius is always at 90 degree from the tangent. It is always like that. You can never change that fact. If the radius and the tangent both are meeting one single point, the radius and tangent, both of them will be at 90 degree all the time. For example, if I'm drawing a tangent over here, let me say this is the point of contact. If I draw a radius over here, they will always make 90 degree. Okay. So I believe this much is clear over here. Okay, now this is the second image. I'm just showing the example. This is the center. This is the point of contact. If I'm drawing a radius over here, and obviously this is the tangent because it is touching the circle at only one point. Hence, this will be tangent and hence this angle will be 90. Similarly, if I'm drawing a radius over here, this is also tangent because it is touching the circle only at one point. Hence, I say this angle is also 90. So far, so clear.
Yes.
Yeah. Now, the second property, the first property I've already discussed, radius is always perpendicular to the tangent. But the second property is the tangent segments to a circle drawn from a point given its wait. Tangent segments to a circle drawn from a point given in its exterior are congruent. For example, segment PA and PB are congruent. I'll explain what this is. Let us consider there is a circle over here, as you can see. Now let us consider a point which is outside the circle. Now from that particular point, if you try to draw two tangents to this particular circle, like this is the first tangent, tangent number one, which is touching at point A in the circle, and this is tangent number two, which is touching at point B in the circle. Now when you observe the distance between PA, let me say, for example, let me say it is 10. And when you measure the distance between PB, you see that this is also having same distance. So these two segments, PA and PB, where P is the common point from where both the tangents are drawn, A is the point of contact of the first tangent, B is the point of contact of the second tangent, then PA and PB, both segments are congruent because both will have same measure. Okay, this is the second property. So we have learned two properties. The first property is radius is perpendicular to tangent, and the second property is whenever you have a circle from an outer external point, if you are drawing two tangents, then this particular length and this particular length both are same. These are the two properties. Yes, Naitik, tell me.
Sir, how did they get this that they are always congruent?
There is a proof which is not discussed with you guys right now because I am assuming because the proof is lengthy, most probably वही reason की वजह से आपके साथ discuss नहीं किया होगा. But yes, there is a proof. Right now it is not our concern. Most probably next year
Okay,
आपको वो proof सिखाया जाएगा.
okay.
Okay. Now, next point. Arc of the circle. ARC. Arc of the circle. Now, what is an arc? I'll just read out the point so that it will be easier for you to understand what is an arc. In the above figure, X and Y are 2 points in the circle with center O. As you can see, X and Y. These are the 2 points. And the center O is over here. They divide the circle. The first part is this part. Like, for example, this is the whole circle. This is the first part. And this is the second part. So these are the 2 points, sorry, two parts of the circle. Who is dividing the circle into two parts? X and Y, obviously. Now the first part, आप बोलोगे हाँ, first part is नीचे वाला part, second वाला is ऊपर वाला. So it's not so professional to say the lower part or upper part. It is always better to give some authentic terminologies. Hence what we do, x और y के बीच में नीचे वाले part में we give a new name. मतलब एक और additional point add कर देंगे. So we have added one additional point. That point's name is A. And upper part में we have added one extra point. That point's name is B. Now you might think कि सर ये जो एडिशनल पॉइंट आपने ऐड किया है, इज इट कंपलसरी कि वो हमेशा साइड में होना चाहिए? नो, यू कैन पुट इट एनीवेयर. यहाँ पर डालना है डालो, बीच में डालना है डालो, ये साइड में डालना है डालो, नो वरीज. सिमिलरली ओवर हियर आल्सो, यू कैन पुट इट ओवर हियर, बी, और मे बी हियर, और मे बी एकदम सेंटर, or maybe anywhere. It doesn't matter where you're putting. It doesn't matter at all. All matters is you have to give a name. That is compulsory. So this particular curve will be called as XAY. This particular part of the circle will be called as XBY. Now this parts XAY or XBY, these parts are called as R. Okay. As you can see, XAY, it's a small arc. XBY, it's a big arc. Therefore, the small arc is called as minor arc, XAY. And XBY, since it is a big arc, we call it as major arc. And if somebody is asking, sir, how to create an arc? Now, do we have to create circle and every time break it? See, one procedure to create an arc is very simple. You simply draw one circle and break it. And जो बचा हुआ है उसको erase कर दो. Whatever is left is an arc. This is one option. Otherwise, another option is what? See, whenever you create a circle, you basically join from center only you create it, right? So you take the center, instead of creating one full circle, you simply create a part circle, a partial circle, a half circle, or maybe a simple small part of the circle. This particular thing is also called as arc. Arc. By the way, this is a spelling error. This is not E, this is ARC. They have written ARE, which is a printing error. Okay. Now the second point about arc is if AB is diameter of a circle as shown in the figure, uh, then each of the arcs APB and AQB, this is Q, AQB are semicircle. So if I'm drawing a diameter, the diameter will also have 2 points, which are dividing the circles into two equal halves. So if AB is dividing the circle into two parts, then since both the parts are equal halves, we call them as semicircle. So this APB and AQB both are semicircle. Now the next point about this is, as shown in the figure, angle XOY is the central angle of minor arc of XAY. For example, let me consider this particular arc between X and Y. As you can see, there are two arcs. The first arc is XAY. The second arc, let me call it as B. The second arc will be XBY. So in this case, the angle XOY will be called as the central angle of minor arc XAY. So whenever there is an arc, there will be an angle as well. And that angle is called as central angle. Yes, Naitik?
So the central angle of the major arc would be 360 minus angle XOY, right?
Yes.
Okay, sir.
Hmm. Because for a circle, the complete one full circle's angle is 360 degree. Hence, from 360, if you remove this, let me say x. So whatever is remaining, that will be 360 minus x. Okay?
Okay, sir.
Just a minute. Let me connect this laptop to the charger. Just a minute. Okay. So, yeah. Proceeding further. Now, in the given figure, minor arc PXQ, PXQ can be named in any one of the following ways. Arc PXQ. So you can call this particular arc as arc PXQ, or it can be called as arc QXP, QXP, or it can be called as PYQ, or it can be called as QYP. So in any particular direction, it can be called. ऐसा कुछ left to right का कुछ compulsion है नहीं. And if you see that inside an arc there are more than one points, you can use any of those points to represent the arc. So it is not compulsory that you should always use only one particular point. ऐसा कुछ compulsion नहीं है. I hope it's clear. Was it clear? Am I audible?
Yes, sir.
Okay, that's great. So next one, angular measure of the arc. The measure of the corresponding central angle of minor arc is known as angular measure of the minor arc. Angular measure means kitna angle hai. Is it 20 degree, 30 degree, 50 degree, 60 degree, 75 degree, 90 degree, how much it is. So that particular measure is called as angular measure of the arc. Now, for example, in the above figure, M means measure. Measure means जो भी value है. Measure of arc AQB is angle AOB. We read this as measure of arc. AQB is equal to measure of angle AOB. So if somebody is asking what is the measure of this particular arc AQB, we'll say yes, whatever is the angle, that will be the measure of arc. The angular measure of the minor arc is 180.
It is in physical book. It is given smaller than 180 degree.
That makes sense actually. So dear children, minor arc means what? Minor means chota wala. So chota means what? It is less than 50 percentage. Okay, because in a circle, total angle to 360 hota hai. So minor means what? Something like this. Now I know that this much is 180. So this will be less than 180. Am I correct or not? Every time it will be less than
Yes.
180. So whenever you listen to the word minor, you understand that minor मतलब छोटा वाला है. छोटा मतलब less than 50%, less than half. So 360 का half is 180. Less than half will be less than 180. Now the angular measure of a minor arc will always be less than 180. Okay. The next point says, in the above figure, arc APB is the major arc of a corresponding minor arc AQB. APB is the major arc, so it's obviously understood this is major arc, and AQB is minor arc. The measure of arc APB is 360 minus arc AQB. So, as I've already in the previous, just like 5 minutes before only, we have discussed this particular point. So, the measure of any particular major arc is always 360 minus the measure of minor arc. जैसे कि 360 माइनस एक्स करके मैंने तुम्हें ऑलरेडी एक्सप्लेन किया था. सो दिस फॉर्मूला इज प्रीटी इंपॉर्टेंट. Okay. And the next point is angular measure of the major arc is always greater than 180. It's obviously understood. If it is major means greater than half above, and that means greater than 180 तो होना ही है. The next point is the angular measure of the semicircle is 180. Obviously, semicircle means exactly equal to half, which means it will be equal to 180 degree. The angular measure of the circle is 360. So this is the last point regarding the arc. So regarding arc, is it clear?
Yes.
Okay. Now the next one, circumference of a circle. The perimeter of the circle is called as circumference. Circumference means what? The boundary. Like this boundary line is called as circumference. Like the length of this boundary line is circumference. So it is generally denoted by the symbol C. So we have a fixed formula with the help of which we can easily find how much is the length of this boundary. As I've already told you, the length of the boundary is called as circumference. So the formula to find the circumference is either pi d. Uh, do you know what is pi?
So
Yes,
3.14
sir.
or 22 by 7.
Yes, it's either 22 by 7 or it is 3.14. Okay. 3.14 is an approximated value. 22 by 7 is comparatively, accurate value. So pi is a constant. Pi has a constant value, which is used to find the parameters of the circle. Now the symbol is basically two straight lines and one hat, or maybe one slant line which behaves as a hat. So circumference's formula is pi multiplied by diameter. This is circumference's formula, one formula. So if you know the value of the diameter, you simply put it. But at the same time, you also know that diameter is equal to 2 times radius. So instead of writing diameter one time, you can write 2 times radius. So pi multiplied by 2 multiplied by radius, which can also be written as 2 multiplied by pi multiplied by radius for the sake of understanding or for the sake of just saying it. Yes, Naitik, what's your query?
Sir, which one is accurate value of pi?
22 by 7.
Okay, sir.
So even 22 by 7 is approximated, right? Like actual
Yes.
is 3.14159 and like infinity more decimals.
Mm, uh,
3.14. 22 divided by 7 is actually the simplest and purest form.
simplest
Yeah.
and
No, it's
purest.
like,
Yeah,
yeah, correct.
It's a recurring decimal.
yes.
It's represented in recurring decimals, but actually it's not.
Yeah, 22 by 7, it's the simplest form, but yes, ideally speaking, the real value of pi is not 22 by 7. It is even a bit complicated than that, a bit more complicated. Okay.
तो 22 by 7 में 142 आता है, एक्चुअल में 141 है.
हाँ, उसके आगे लेकिन round off okay. Yeah, again,
हाँ,
as I've
correct.
already told you. Yeah. So the real deal is something else, but in our, you know, handling such a big number is not a joke. So our scientists have decided कि हाँ भाई 22 by 7 एकदम करीब करीब आ जाता है, so we can go with that. Just a minute. Okay. Yeah. Now going to the next part, length of an arc. As shown in the figure, if O is the center of the circle with radius R, O is the center. Radius means either this length is R or the other length is R. Okay. Theta is the angular measure of arc XAY. XAY का angular measure is theta. Then the length of the arc. What is the length of the arc? This particular length. ऐसा ये curvature का जो length है, this length can be written as theta divided by 360 multiplied by 2 pi r. Okay, this is the formula. Theta divided by 360 multiplied by 2 pi r, where 2 pi r is what? It's circumference in short. Circumference का जो value है वही दिया है. I believe this much is clear.
Sir,
Yeah. Now, this formula is also very important. Now, the next formula which you should remember is basically area of the circle. That is nothing but pi and r square. Okay, simple formula. It is pi r square. That's it. So you must remember this formula. So these are the few formulae which we must remember. The next one is area of sector of circle. So what is a sector? I'll tell you. Yeah. The area bounded by an arc and two radii drawn from the end points of the is called sector. In the above figure, the sector is denoted by OXPY. OXPY. So what is a
sir,
sector? This,
radii drawn by the end points of the.
yeah, end points of the arc it should be. Yeah.
Okay,
So let
sir.
me assume this is arc and arc के end points ने they have drawn a radii towards the center of this circle. And this particular piece where this radii and this arc and this radii is closing, this particular piece जो पिज्जा का piece जैसे दिखता है, this particular piece is called as sector. So this particular piece is called as sector. The sector in the given figure is denoted by OXPY. So basically arc दिखाने के लिए 3 letters तो है ही, center दिखाने के लिए एक और letter, कुल मिलाकर 4 letters होने चाहिए. Total there must be 4 letters. In the above figure, sector OXPY is a minor sector. जैसे minor arc है, वैसे minor angle है, वैसे ही minor sector है. Yeah, OXPY is the minor sector, and OXQY is a major sector. Area of the sector can be expressed as theta upon 360 multiplied by 2 pi r. जैसे कि you have seen the earlier formula, the length
So it should
had,
be pi r square, no? So
yeah, it should be pi r square. The length had theta by 360 multiplied by 2 pi r. The area has theta by 360 multiplied by pi r square. I hope it's clear.
so
Yeah, just a minute. What is a segment of a circle? The area bound by an arc and the corresponding chord of the circle. For example, this is the arc and this is the chord. जो भी इसके बीच में आया हुआ area है, that area is called a segment. Now, just a minute. Now, in this case, now since this arc is minor arc, the segment will be called as minor segment. And this segment corresponding to the major arc, for example, this is a major arc. So this segment, which is corresponding to the major arc, is called as major segment. Minor segment, major segment. Okay. Now, how to find the area of the minor segment? It's a very simple concept how to find the area. Before we go into that, let's do one thing. Let's exit the meeting and join again, please.